In this lecture, I will share a very important topic of physics that is known as Coulomb's Law. Coulomb's Law in electrostatics. What is meant by Coulomb law? Suppose we have 2-point charges. Point charges means very small bodies having charge on them. Suppose one body has charge Q1 and the second body has charge Q2, and these two are separated through some distance r, let us suppose. If these two charges are similar, they will repel each other. If they are having opposite signs, they will attract each other. Coulomb law tells us what will be the magnitude of force of attraction or force of repulsion between two point charges. According to Coulomb law, force of attraction or repulsion between two charges is directly proportional to product of magnitudes of charges on two bodies and is inversely proportional to square of the distance between 2-point charges. Combining the two, we can write F is proportional to Q1 Q2 upon R square, means inversely proportional to square of the distance. In order to remove this sign of proportionality, we are to introduce a constant of proportionality. Let us suppose it is K R square. So this formula is nothing but Coulomb's law in electrostatic. With the help of this, we can calculate force between two point charges. Now the question is, what about this K? What is the value of this constant of proportionality? The value of K depends on nature of the medium between the two charges as well as on the type of units we are using, whether we are using C.G.S. units or SI units. Let me talk one by one. In SI units, the value of constant is given as 1 over 4 pi epsilon. This symbol is known as epsilon. And what is epsilon? It represents permittivity. Of the medium between the 2-point charges. It is the property of medium between the charges. So using this value of K, I can write F is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square. So this is the form of Coulomb law in SI units. When I talk in C.G.S. units, the value of K is equal to 1 upon capital letter K, where this capital letter K represents dielectric constant of medium between the two charges. It is also property of the medium. So using this, I can write F is equal to 1 upon K Q1 Q2 upon R square. This is the form of Coulomb law in C.G.S. units. If the medium between 2-point charges is air or if there is vacuum between the point charges, suppose these are 2-point charges, again Q1 Q2, separated through distance r. Air, if I have air here or there is a vacuum between the charges, then what happens in SI units, the permittivity is symbolized as epsilon naught, not by epsilon. Epsilon is used for any medium. Epsilon naught is specially used when the medium is air or if there is vacuum. Then Coulomb law becomes 1 upon 4 pi epsilon naught Q1 Q2 upon R square. And this value of permittivity of air or vacuum is constant. It is 8.85 10 raised to power minus 12 in SI units. Using this value and putting the value of pi, we get F is equal to 9 into 10 raised to power 9 Q1 Q2 upon R square. So this is more simplified form of Coulomb's law. Similarly, when I talk in C.G.S. units, then there is dielectric constant, and dielectric constant of air or vacuum is 1. So using this value, Coulomb law can be written as Q1 Q2 upon R square. This is again simplified form, especially when medium is air. So I can write here F with medium air. Here also in SI units it is medium air, or if there is vacuum between the charges. One thing more I would like to share, that dielectric constant and permittivity of medium, these two are related to each other by the formula K is equal to epsilon divided by epsilon naught. Means dielectric constant is a ratio of absolute permittivity of the medium to permittivity of air. And this ratio on right hand side is also known as epsilon r. Epsilon r means relative permittivity of the medium. This formula is very useful in solving some numerical problems. Let's take an example. Suppose there are 2 point charges Q1 and Q2 held in some medium and separated through some distance r. Question is, what will be force between the two? We are given, suppose Q1 is same as Q2 and it is 0.65 microcoulomb. It is given to us. Distance between the point charges, suppose it is 50 centimeter, and the question is, what will be Coulomb force or force of attraction or force of repulsion between the two charges? We shall apply Coulomb law. First of all, let me convert the units. 0.65 into 10 raised to the power minus 6 coulomb, and this r can also be written as 50 into 10 raised to the power minus 2 meter. So using these values, I can calculate F is equal to 9 multiplied 10 raised to the power 9 Q1 Q2 upon R square. 9 multiplied 10 raised to the power 9 Q1 0.65 into 10 raised to the power minus 6 into 0.65 into 10 raised to the power minus 6 divided by R square, means 50 into 10 raised to the power minus 2 into 50 into 10 raised to the power minus 2. So we are calculating in SI units. So after simplification, we can get F is equal to 1.9 into 10 raised to the power minus 4. This will be the answer. Now what will be units of force? Because we are using everything in SI units, force will also be in SI and answer will be in Newton. So much force will be exerted between two point charge.